Our time is exactly 7:40. We can start with our class. I've noted your concern, but let me remind you that you are going to write a quiz at 1 o'clock today. We are going to write a quiz.
Sir,
Yes.
what if
Yeah.
by 1 o'clock what if our devices will be on battery low?
We will see when the time arrives.
Okay.
Let's not presume. We'll see that when the time comes. Okay. We are on chapter 5, if I'm not mistaken. Yes, it's chapter 5. And I've already given you the theory part of it. So today we are going to start with example 5.1, which I suppose we've already started that one. So let me just quickly go to the window journal so that we can start with our lecture. Okay, just wait a bit. Wait a bit while I'm going there. Okay. Okay, there we are. It's lecture number 16. Number 16. And then we're going to start with example 5.1. For those who are having lecture notes, page 51, not 51, 39, sorry. Page 31, 39. Page 39 in the lecture notes. Okay. And I think I have already explained before what is it all about. But now let's consider the given information here. Remember, we just want to estimate the total weight of apple juice. Okay. So in our case, we said it's a total sugar content, if you still recall. That is tau y hat. Okay. We just want to estimate tau y hat, which is a what? The total weight of apple juice according to the notebook. But in our case, when we were doing that, we said it's a total sugar content. It's the same thing anyway. So the given information there on example 5.1, we have got the sample size, which is equal to 15. You can say 15 apples. And then we've got the total weight of orange, or sometimes you just call it the total weight of apples, because in the lecture notes they talk about the apples. In our example, we talk about the what? The orange. So you can rather say is the total tau hat. I mean the tau x. Sorry, tau x is the total weight of orange, or you can call it a total weight of apples. The same thing anyway. So it's given there. They give us 2,000 pounds. 2,000 pounds. the total weight of orange or total weight of apples, which is tau x equal to 2000. Now, remember our main idea is to estimate the total weight of apple juice, or the total weight, the total sugar content, sorry, which is tau y. So tau y in ratio estimation is defined by R tau x. Okay. Where R is the ratio estimator, remember, which is equivalent to R is equal to y bar over x bar times tau x. Okay. So if you check the table there on page, or is the output from the Minitab software, they gave us the descriptive statistics of apple juice y and weight x. Down there, they wrote variables, and then they said population size. That one is not a population size. Big N. It's not big N, it's a small n. It's a sample, okay? So you can change that to be a sample. Then they gave you a mean of apple juice. Remember, we just want to estimate the total weight of apple juice. And they gave you what? The weight of apple juice represented by variable y. Okay. And then they gave you the weight of apple, which is weight x, and the mean of that is 0.2880. Let me just add it here. Our y bar, which is the mean of apple juice, is 0.19. Okay, this is 1900 according to that table, and the mean of the weight of an apple is 0.2 0.2880. Okay, those are the information. So according to the formula of estimating the total weight of apple juice, it's equal to y bar divided by x bar times tau x, which is equivalent to what? Y bar is 0.19. Okay. Then you divide by x bar, which is 0.2880. Then you multiply by the total weight of apple, which is 2000. Those who are using a calculator, may you please assist us? What is the answer there?
19.44.
It's 1319
44.
Yeah, so it's in 3 decimal places. How many fours? 3 or 4
Another
or
4.
2? Okay.
4. So we'll choose switch it now.
Okay, that's it. That is the what? That is the estimated total weight of apple juice. Okay. So that was the first question. Did I give you the question before?
No, sir.
Oh, sorry for that. I thought maybe I wrote it down. Let me just write it down so that you can follow. Because number A, you have to estimate. Let's say you use a ratio estimator But the question is there. Use the ratio estimation, okay, method. Ratio estimation method or ratio estimation to estimate the total used to total weight of apple juice. So on the lecture notes, they just say use ratio estimate to estimate the total weight. So it's not the total weight, it's the total weight of apple juice, or you can use what? Total sugar content. It's the same thing. That's number one. Use ratio estimation to estimate the total weight of apple juice or total sugar content. It's the same thing, which is what? Tau y. So you need to find this. That's question number one. Sorry. That's number one. Number B, it says calculate the estimated variance of that estimated of that estimator estimated there in part A. So it says calculate the estimated variance of tau y. You're calculating the estimated variance of the estimator that you have estimated there in what? In part A. So in other words, you have to find what? Estimated var of tau y hat. So this is what you have to find. So how do you do that? I think I gave you a formula. So the estimated var of estimated population total under ratio estimation, it's equal to what? You can tell me, what is the formula there for the estimated variance of the estimated population total under ratio estimation?
Tau x
Estimated
divided
var is what?
tau x divided by x bar
Tau x divided by x bar
into tau x divided by x bar minus n
tau x divided by x bar minus n
close bracket s squared, the variance, multiplied by r over n.
It's not multiplied by r, it's SR squared. That R stands for the ratio, okay? Yeah, it's SR squared. SR squared stands for the variance, estimated variance under ratio estimation. Okay. So now, you can tell me, why did you use this formula? Why did you use tau x over x bar? Not, remember, we have this one as well.
We are not given the population size.
Yes, because they didn't give us the population size. Okay, so that is why we're using that one. Okay. So now let's substitute and get the answer. Tau x is equal to what? 2000, isn't it?
Yes.
X bar
0.2880.
0.2880 open brackets 2000 0.2880 minus sample size is what is 15, remember? Then you close the brackets. What is our estimated population variance under ratio estimation? You can tell me.
0.018528.
0.018528. It's a what?
5258
It's a what?
is the SR squared.
It's S squared.
Yes.
No, that is
No,
a
it's our
standard
S, so
deviation.
we have to square.
So
It's our S,
yes,
yeah.
thank you very much. You have to square that one. Those are the mistake. Those are some of mistakes that are you making on the test or quiz. You must know the difference between the standard deviation and the variance. If you have been given the standard deviation and you want the variance, you have to square it. Okay. So that means we're going to square 0.0185258. Then you square it. Okay. Then you divide by n. N is what? Is 15, sorry. So n is 15. Then later you can give me the final answer then.
1101.
110 110
1
1.029
029. Yes.
like this. In my case, I got 1101.012. Are you all getting the same answer? Which one are you getting? I mean,
The first one, sir.
all of you are getting this one. Okay.
Yeah.
If that is the case, so I made a mistake. Let me cancel it. So the answer is 1101.029. Okay. Now, let's find a bound on the error of estimation.
Sir, sorry, sir.
Yes. Yeah.
Can you go back to A? I just want to confirm something.
Okay. Let me just go. Yeah.
Yes.
Mhm.
Okay, thank you.
Okay, then. Now, let's find a bound. Bound on the error of estimation for the population total. So in other words, number C, you have to find a bound on the error of estimation for the estimated population total. Yes. Mm.
How did you get SR squared?
Remember, SR squared is the variance, is the estimated variance under ratio estimator. So now, if you can check on the lecture notes there is an output. Do you have a lecture note with you there?
No.
Do you? Do you have or you don't?
I will open it just now.
Yeah, just open it so that I can show you where did you get it from.
You are on page number.
Page 40. 40. There is a table up there, and there is an output, regression analysis. You see that?
Yes, I'm there.
Then there is a regression equation of apple juice. Before that, after that, there is a predictor, coefficient, standard error coefficient, that smaller table there. You see that? With constant in weight. Then below that, there is S equal to 0.0185258. Can you see that? Then followed by
Yes,
R
yes, I can
squared
see.
and R squared adjusted. So we took S equal to 0.0185258 as our standard deviation under ratio estimation. Okay. Then we square it. Are we together?
Yeah.
Okay, now let's find a bound.
Okay. Thank you.
Okay. Bound is equal to 2 times the square root of the estimated var of tau y. So it's the matter of substituting what? 1101.029. What is the answer?
66.364.
66.364.
364.
Okay. That is a bound. Now, let me just quickly go to show you how to select the sample size under ratio estimation. Or before that, do you have any question? Before we go to the sample sizes. Any question? None. Okay. Let's quickly go there. Now we are selecting the sample size. Under ratio estimation, okay? I want to show you the formulas that you can use to select the sample size under ratio estimation. So in other words, how do we select a sample size under ratio estimation? So now, the sample size required to estimate the population ratio. Sample size required to estimate the population ratio. To estimate the population ratio. Is given by n equal to population size times the population variance under ratio estimation divided by n, which is the population size, times d plus the variance, where in this case our d is equal to, remember, we're estimating the population ratio. That means it's r, isn't it? We're estimating r. So our d now is equal to bound being squared times mu x squared divided by 4. D is equal to b squared times mu x. This is mu x squared divided by 4, where mu x is what? Is the population mean of weight of an orange, or is the population mean of weight for an apple? That is mu x. So now, what about the sample size required to estimate the population mean? Population mean. So which is what? Mu x. To estimate the population mean, sorry. To estimate this one. So it's going to be equal to what? It's equal to the same formula, n, which is stand for sample size, which is equal to the population size times the variance divided by population size times d plus the variance, where in this case our d is equal to b squared over 4. Can you see the difference between the two? The first one here, okay, which is the same as this one. So it's the sample size required to estimate the population ratio, but our d is equal to b squared times mu x squared divided by 4. So here, the sample size required to estimate the population mean is equal to this. It's given by this formula, where d is equal to what? B squared over 4. So you have to take note of that. Okay. So now the last one, the sample size required to estimate the population total. So the sample size required to estimate the population total. Population total. In other words, we're talking about what? The y. So it's given by, so it's the same formula, sigma squared over n times d plus sigma squared. So now, in this case, our d is equal to what? B squared over 4n squared. The only difference is at d. So that's it. Any question? Before we go to example 5.2.
Say,
Yes.
is it population total? Is it TY there?
Yeah, yes, it's T1.
Okay.
Now let's go to the example now. Sample page 41. Example 5.2. page 41 on our lecture notes. Okay. Here, actually, we just want to estimate the average number of trees per acre on 1,000 acre plantations. I won't read everything, but anyway, we just want to estimate the average number of trees. Okay, which is what? Average number of trees. So we want to estimate, sorry, we want to estimate mu y hat. This is what we want to estimate, okay? And they gave us the population size of 1,000, okay? And gave us the mean number of trees, which is what? Mu x equal to 19.7. I think that those are the information given there. Okay. So now remember, we said we want to find mu y estimate, which is equal to r mu x. Remember? Do you remember this formula?
Yes.
Which is equivalent to what? To y bar over x bar mu x, isn't it? And on that example, they gave you a table. Table 5.1, and the x bar and y bars are given there as well on that table. On the last, second last row, there is a mean there, and the last row there on that table is a standard deviation given. So what is our y bar now? Y bar equal to? Anyone? Are you there, guys?
Yes, yes.
Yeah, I need y bar.
22.10.
Yes, 22.10. X bar?
20.80. Yep.
20.80. And mu x is what? 19.7. What is our answer now? Anyone?
20.93.
Yes. 20.93
931.
what? 31.
One.
Okay. That's it. Thank you very much. Now, I forgot to give you the question. I thought maybe everybody's having that lecture notes. But anyway, let me just write it down. Question number 1 says what? Estimate the average. The average. They're saying the average number of trees. Okay, which is what? Mu y hat. So you want to find this one. Okay, so that is what we did. Number B, it says calculate an estimate of the population variance. Actually, that R there, this one, sorry, there is an R here. These are simple means that we are dealing with the ratio. That is the population variance under ratio estimation. Even here, we didn't write R, but you can just indicate R if you just want to indicate that indeed we are dealing with the what? The ratio estimation. You can put R. There is no harm on that. We can put R, you cannot put R, as long as we know that we are dealing with what?
Sir,
The ratio estimation.
sir.
Okay. Yes.
I think I'm lost. Where is this 22.10 from?
22.
And
Oh,
these two
22.10.
values.
Do you have a lecture notes? Page 41, are you there? Page 41.
Where I see, sir.
Okay, thanks. So here you can just say calculate an estimate of the population variance under ratio estimation. So that R, you just indicate that we are dealing with the ratio estimation. Even though if it's not there, there's no harm. If it's there, there's no harm as well. So how do you estimate the population variance under ratio estimation?
Sir,
Yes.
to estimate averaging the population mean yi. So what if I use the means? I use the sums instead of the means.
The sums.
Yeah,
Why
I
are you
see
using the sum?
summation
Which
of.
sums are you talking about?
I'm talking about summation of yi from I equals to 1 to n.
Oh,
Divide by
you come up
summation
with
of.
yes. In other words, you are coming up with your own calculations.
But I'm getting the same answer.
Yes, but it's advisable to use what is given
I mean, in
because
case
you
you
can
don't
find
give,
that there
in
is a
case you don't
difference
give,
in terms of rounding.
I get you. You may find that
Yeah,
you don't give me the means. I guess not always the case. You'll give me the means. I'll have to calculate.
definitely you are right there. But if it
Yes.
is given, please use what is given there. Because if you can use yours, you can find that it is slightly different from the given one, and you are going to get the wrong answer.
So there's no way it will
But
be.
if it's not given, you can use whatever is given the what you call the
Okay.
X I's and Y I's, so that you
Okay.
can get the average. Did you get that? Okay. So now to estimate the population variance under ratio estimation, you know that it's like S. Oh, let me start here. It's a sigma squared R. So you put an estimate because you are estimating it, isn't it? Which is equal to what? SR squared. Do you agree? Which is equal to, then you put the formula. Okay? Which is yi rxi. You still remember this formula? Then you square it, then
Yeah.
divide by n
N
minus
minus
1.
1.
Yes. So you use this formula. You know how to calculate it, isn't it? But in this case, it's given. Can you show me there? Is it given? Yes, it's given there. So there's no need to just use this formula. You're going to waste your time. What is the estimated variance there?
It's 2.06.
2.06 is a standard deviation.
I mean 2.06 squared, sir.
Definitely, yes. 2.06 squared. That is your variance. What is the answer there? 2.06 squared is equal to what?
4.2436. 2.
4.224.
Yeah, 244.
Yeah, 44. So that's it. So that is the estimated what? Population variance under ratio estimation. Okay, it's fine. Now let's proceed. Number C. But remember, if it's not given, so you have to calculate it using the formula, this one, which is straightforward. Now let's estimate, or let me just say calculate the estimate, or let's say the estimated variance of the estimated mean, which is mu y. How do we calculate that? Sorry.
It's
Come with the formula.
it's n minus the sample size divided by
Hey, you start with it. We start with this estimated var of mu y hat equal to what? Then it's n minus
n minus the sample size n minus 1
n minus
times
1.
yeah
Which n are you talking about? Is simple
the population one.
like this.
Yeah. Then times the estimated variance
No, sir.
of the ratio.
It doesn't have
I'm
n
writing what
minus
it's
1.
saying.
Eh? Oh no one.
Yeah,
Why are you
Oh.
saying n minus 1 here?
Yeah. Tumaliwa boy. Oh, sorry, sir.
Just rectify yourself, please.
Yeah, it's not one.
Yeah, so it's what?
It's n.
It's n. Thank you very much. So be careful. Okay, now what is our population size now? It's 1,000, isn't it?
Yeah, 1,000.
Then sample size is what?
10.
10.
10. Thank you. Then 1,000. Then multiply by that estimated variance, which is what? 4.244. Then divide by sample size 10. The answer is what?
To
3 decimal places.
0.420.
0.2. 0.4 of 0.2.
0.42.
For 2 what?
0.
0.
Yeah.
It was 0.419 before.
Which one, sir? The answer.
You have rounded. It's like that. It's
Oh,
0.420.
420,156.
Oh, okay. Okay, so it's fine. So because in my case I got 0.416, so that is why I'm asking that.
Okay.
So that means in my case I think I used the wrong thing there. Okay, it's fine. All of you got 0.420, isn't it?
Yes, sir.
Yes.
Okay, it's fine. Now let's go to number D now. Number D says what? Determine the sample size. That's number D. Says determine the sample size. needed to estimate mu y. Let me write nicely because mu y with a bound on the error of the estimation. Of estimation. Of magnitude. B equal to 1.0. That is the question. So obviously you're going to use this formula. N equal to so N is equal to N times sigma squared N times what? B squared over 4, isn't it? Plus sigma squared. That is the formula. Then you substitute population size, again 1000. So because here we don't have the population variance, you use the estimated one, isn't it? You have to use this one. Are we together? So that means it's 1000 times, what is the estimated one? 4.244. Then you divide it by 1000, multiply a bound equal to what? It's 1 squared over 4, isn't it? Then you add what? The estimated variance. What is the answer?
16.693.
16.693.
Yeah.
Okay, because it's a sample size, you round it off to 70. Are we together? Any question before we go to the last example?
So say, why do we use the sample variance instead of the population one?
Because there is no true population. Do we have the true one?
No, we
use the
don't
one
have.
that we yeah, we don't have. So
if
we
we
use
don't
the
have,
yeah,
we used to. Okay.
yeah, we use the estimated one. Let's go to example 5.2a. It's on page 43. Example 5.2a. Don't know why did I say it 5.21a. It's on page 43, lecture note. Yes, for that one, a long story, so you can read it on your own. But we just want to, let me just write down the question. Or maybe you can take just 2 minutes to read it, to read that paragraph so that you can understand it better. In the meantime, let me just write a question for you. It says determine the sample size. Which is the number of items needed to estimate they say tau y, the population total, with a bound on the error of estimation of magnitude B is equal to $500. Let me just say 500. Okay. So now let's go back and check the given information. Given information, they gave you what? They gave you a population size, isn't it? They gave you a population size. N is equal to what? 2,100.
Yeah.
Yes. And then another given information, tau x equal to what?
It's 45000.
45000 dollars. Okay. Then they want us to do what?
To
Remember,
find
to
the,
determine the sample size. Okay.
yes,
For what? For tau y estimate. So now we can just start. Let's start by calculating. Before we come to this question here, let's start by calculating the estimated population total. This one, isn't it? For just additional information. So tau y hat is equal to r, isn't it? Tau x, sorry. Tau x. R is equal to what? Y bar over x bar. Tau x. So there is table 5.2 on page 43 there. Okay. What is our y bar? What is our x bar? X bar. Can tell me what is our x bar?
yeah,
16.13.
16.13.
Yeah? Y bar.
15.83.
X bar. 16.83.
Well, I was asking about y bar. It's 15.83,
83.
isn't it? Then x bar 16.13. Then multiply by tau x 45,000. Then give me the answer.
The answer is 44168, comma 050.
441 what? 68.
Yes. 63, man.
63.
Yes.
Point what?
0.050.
Okay. Can you find the estimated variance then? Find the estimated variance of that estimated total. Can you find that? Give me the what you call the formula. It's what? N open brackets.
N minus A.
Isn't it? Then SR squared over A. So our N is what? 2100 2100 minus, what is our sample size? We don't have a sample size. Okay. So we can use what? Tau x over tau what? So that means because you don't have a so it won't work.
Tau x over x bar.
But the issue is we don't have the sample size there.
Yeah, it's 7.45.
Isn't it 15 the sample size, sir?
Huh? Let's
We have
calculate the
we
sample
have
size
the
first.
Isn't it the
we
sample
have the
size?
standard deviation. So we can
No.
find the sample variance.
So is it not 15?
The sample size. Oh yes,
The
it's
sample
there.
size is
For what? Let me check.
We have 15 items.
Oh yes, that's 15. Yes. Yeah, it's there. Sorry. So that means it's there. So it's possible. So it's 2100 2100 minus 15. Then what? Sample variance is what?
It's 7.4529.
What? Come again, sample variance?
Say, on the table we have the standard deviation.
Yes, but it's the matter of just squaring that thing.
Yes, I did. It's 7.45.
Also, you should have told me that you have already squared.
Okay.
Oh, it's what?
7.4529 or
Let me
3.
just write this one so that
7.453.
people can follow. Divide by 15. Because if you can just write the answer there, somebody won't understand. Okay, the final answer is what?
2,100,000. Isn't it, sir?
Millions.
Oh, Morose, oh my God, what am I getting here? Let me see.
Millions.
What is the sample size, sir?
Sample size is 15.
What is the population size? Oh, wow.
2100.
217.
That doesn't make sense.
Does it make sense?
It makes sense, sir.
What is the answer?
The answer is
217.
1755.
0
0
1,
1
comma
comma
51.
51. The variance is too
They
big.
say 2, sir. You
Huh?
You
You
forget
forget
the
the
2.
2.
The first digit.
I can't get you. Remember, this is the question
answer
that we
is 217.
Sir,
Mm.
the first value is 2.
The first value is 2. So this one is incorrect.
No, I said
It's
it's
correct.
2. It's correct.
Ah.
You read correct.
Why I
You
said the
left
first value?
2.
You left 2.
I'll
It's
repeat it again.
217.
Repeat it again.
17550.
175.
2, say.
217. 217.
Oh, 217.
5501. Yeah. 51.
Now remember, this question we just formulated, it was not there. So we are just calculating it. It was not there. Anyway, let's leave like that. Then what about the bound there?
Say, isn't this a million?
246, yeah, it's a million. You're right.
So I'm surprised when you're surprised when I say 2 million.
I'm surprised because it's too big. The variance is too big. So maybe it's because we just formulated the question. It was not there at all. I just wanted to show you how to calculate the estimated variance of the population of the estimated population total. It was not there. So if the answer is this one, shows us that we just force it. Oh, so the bound is what?
The bound is 2949.916.
Hey. You see, even the bound is so scary. Okay, it's fine. Okay, let's go to the correct question now. The one that I've asked there. Determine the sample size needed to estimate the population total. Let's answer number A. The rest we were just including them. They were not there at all. So let's answer number A. The formula is what? N equal to N times sigma squared N, because now we are dealing with the totals, so it's going to be B squared over 4, isn't it? Is it total or is it which one? Over 4n squared. It's like this, isn't it? Sigma squared. So because we have not been given the population variance, we estimated it to be SR squared, isn't it? So it's B squared over 4n plus SR squared. So then when we substitute 2100, yes. I thought maybe you're talking.
Hello, sir.
Yes.
Oh, yeah. So I just wanted to inquire about the quiz.
The quiz?
I just wanted to inquire about the quiz. Pardon me for joining late, sir.
Okay, I'll answer you late after. Let me finish this one.
Hey,
so
the
formula is
my
correct?
device is gonna switch off and I'm having connect.
The quiz is still on. You're still going to write a quiz at 1 o'clock. If there is something, we are going to communicate.
But we are having electricity issues, sir, and
for
as well as water.
For now, isn't it?
So it's set to come back at 5. Everything is set to be coming back at 5.
Did you get any message?
Yeah, we got communication.
The municipality letters issued out with this information.
Okay. Let me. I'll communicate with the with the class rep, then I will inform you. After this class, I'm going to communicate with her. Then immediately I will give you the response.
All right. Thank you, sir.
Yeah, let me just finish
Maybe
this.
I
That's
think
why I didn't. Eh?
I'm saying that maybe it would be better if you can just take it to 6 p.m.
Take it to
Yeah, maybe to 6 p.m., sir.
6 p.m. since the estimated time for the electricity to be back.
Oh, we can write it venue based,
Uh,
sir.
okay. Yes, I will communicate
no,
with the
not
class
venue
rep.
based.
Class rep will come back to you. Then you give me the answer. Then I'll decide. So for now, can we please finish this one? Immediately after the class, I'm going to communicate with her.
Yes, let's continue.
Yeah. So I was asking, do you follow these formulas? Do you understand where is it coming from?
Yes, sir.
Okay, now 2100, what is our estimated variance? You said it's 2.73, isn't it? Squared.
Yes.
Then you divide by a bound. Bound is what? Is it 1?
No.
Or
It's
500?
500.
So it's 500 square divided by 4 times what? 2100 plus 2.73 square. Hour. Then can you do the calculations for me?
Yeah, so the answer is 420,561.
4,
20,561.
61.
561.
561.
Yes.
Like this. Which is equivalent to
421.
421.
421. So that means this is the overall sample size. So I think we can stop here and allow me to go and communicate with the class rep, and then we will communicate with you later. Any question?
Can you please go down?
Okay. Any question? So we are going to stop here, and then we're going to meet tomorrow again for another class. So this is chapter 5, and we're dealing with the ratio estimation. So tomorrow we're going to start with a regression estimation. Tomorrow is about regression estimation, then we'll take it from there. Okay, can we stop here? Okay, see you. So we'll communicate about the quiz later.